All right, morning, guys. First thing I'm going to have you start out doing is this is a review problem. This is from Monday and Tuesday, I believe, from Monday itself. This is called a mapping, where we take our input data, this is our input, otherwise known as like our X values. We map them across to our output. I want you to tell me, is it a function, yes or no? And then state the domain and the range. Hopefully you have a good memory of what those are. I'll give you about a minute and a half to do that. So once again, function, not a function, domain and range. All right. So in the chat right now, let's give me a yes or no. Is it a function or not a function? All right, good news, good news. Like what I'm seeing here, this is indeed a function. All right, and the reason being, each of these x values or inputs is only going to one number over there. -3 is going to 5, 1 is going to 5, -2 is going to 11, and 8 is going to 6. It doesn't matter that both -3 and 1 are both going to 5. That's not an issue. It's that they're all going to just 1. So yes, this is a function. All right, domain. Our domain is our inputs. I'm going to put them in numerical order from least to greatest. You don't have to do that. -3, -2, 1, and 8. And I list them with these little squiggly bars here. Set notation. Outputs. Even though 5 is being hit twice, we only write it down one time. So I'm going to go -11, 5, and 6. All right. Anyone willing to tell me what would I have to do to make this not a function? To make this function, or to make this mapping not a function? Looking for a shout out here. Anybody wants to shout it out? All right. Got a chat. Yep. Brandon's got it. If I took any one of these numbers and drew to a second arrow, that would make it not a function. So, for example, if 8 also went to 5, 8 going to 2 spots would make it not a function. All right. Before we move on, anybody have any homework questions from yesterday? Anything we're not sure about?
Can you do number 6?
Yep. So number 6 is actually like the first 3 problems. It's just written in a different way. So I have f of g. My g's are terrible. Of 4. So like problems 1 through 3 up above, you take this number and plug it into the function on the right, work it out, get a number, and then plug it in the function on the left. So g's function is g of x equals 4 times x. So we'll do g of 4 equals 4 times 4. So I'll get 4 times 4 is 16. And then I will take that and plug it into my x or my f function. So my f function is -2x squared plus 3. So I'll go -2 times 16 squared plus 3. If you want to take a second and finish that one, I'll let you do that while I take a sip of my coffee. All right. So as I do this, I got 16 squared is 256. I got negative 2 times 256 plus 3. I got a negative 512 plus 3. Went up with a negative 509. All right. Any other questions from yesterday's homework before we move on?
Can you do 7?
7, yep. We'll do 7. So I got f of g of x. So I'm going to take the g function and plug it into the f function. So I'm going to write the f function out first. Well, the f function is just an x. So I can see why that one's a little tricky. So the f function is just the x. So that means just start out with parentheses. Okay? And then take the g function and plug it in. The g function is x minus 3. So I plug that in. And that's just my answer. That one's kind of too crazy, too easy almost. You're like, what's it supposed to do? Well, it actually doesn't do anything. So if you wanted to, you can get rid of the parentheses, and your final answer is just x minus 3. All right. Just a reminder, I have 2 screens up. Use the one that's muted. It's got a better picture quality. I'm working on getting a separate webcam. It's supposed to give me a wider screen as well. We'll see if that happens or not today. School's supposed to hook me up with that. All right. Any other questions off yesterday's homework?
Can you do number 4?
Number 4, yep. So I got g of f of x. G of f of x. So what that is saying is, once again, start out the g function, write out the g one, but wherever the x is, take it out and put in parentheses. So my g function is for x. So I'm going to go 4 parentheses. Inside of there, plug in your f function. Negative 2x squared plus 3. And now all you can do is simplify that. Somebody want to help us out? Tell us what to do to simplify that function?
You do 4 times the negative 2.
Yep. We're going to distribute that 4. Take 4 times negative 2 and 4 times 3. You'll get a negative 8x squared plus 12. And because these are not like terms, I can't combine them. I can't go 4x squared. I just have to leave that the way it is. All right. Couple announcements here. Tomorrow is test day. All right. So far, I have put select answers from the first 3 homework assignments up. I'll put up select answers from this one in a few minutes or later today after you guys have worked on it for a while. I'll also put up a 4-1 to 4-3 review. Tomorrow, you'll take your test between 10:15 and 11:15. You'll come into Google Meets. I'll open up the test. Once you're done with the test, you're free to leave the meeting. But during the test, you'll have your camera on for test security purposes. So please be appropriately dressed for the test tomorrow, and have an appropriate background behind you. And like I said, once you're done with the test, hey, Mr. Leonard, I'm done. Peace out. Thanks for the day, and I'll see you guys on Monday. I would like it if you guys would do your assignments daily, so that way you're doing them while they're fresh in your mind, so you're not having to go back and do it on Friday. I have some kids who wait till the last day and turn everything in. Everything is due by 3 tomorrow, both the homework and then the test tomorrow you'll take during class. You can use a calculator on your test. Not a big deal. Any other questions as far as the test goes tomorrow? All right. Today's lesson. We have 2 types of problems today. So your test is off 3 pages of a PDF. The first page is the first type of problem we're going to do here. And then we're going to do it algebraic style. And then the third page is kind of a review as well. It does a lot of Monday and Tuesday stuff. So just to give you a heads up what's coming today. So right now, I have a green function up here. How do I know that this is a function? Look at the data and tell me why it's a function.
Can you move your camera a bit? We can't see it.
Yep. Everybody good? Take a look at that data. Tell me why that's a function. Anybody, why is that data a function?
The X numbers are going to an output,
Yep.
and there's no repeats.
There's no repeats on the X's. -2, -1, 1, 3. None of those repeat. These can repeat down in the Y category, but the X's do not repeat. All right. What I'd like you to do right now is I want you to graph the 4 green points, and as you go from left to right, I want you to connect the dots. It's going to make an odd shape. It will not be a line. It'll be a little jagged. So plot the 4 points on that graph, connect the dots from left to right. All right. So as I do this, -2, 1. Left 2, up 1. Green dot. -1, 3. Right here, I'm going to connect those 2. And then I'm going to go to 1, 4. So you can see, not a straight line. And then I'm going to go 3, 5. All right. Today is entitled Inverses of Functions. All right. I have a green function up here. In a little bit, I'm going to graph its inverse in blue. We're going to graph it on the same graph. I want you guys to take a minute, see if you can think what you think might cause the green function to find its inverse. All right, so take about 30 seconds, brainstorm. What do you think would cause an inverse of functions? All right. Looking for some guesses here. Doesn't matter if you get it right or wrong. We want to take a shot at this one. I just give you a heads up. I'm going to wait until somebody guesses. So if you want the class to go a little bit faster, take a shot. Gotcha. All right. Good guess there. Good guess there. What causes inverse? A lot of people say change signs. So go 2, -1, 1, -3, -1, 4. Very good guess, but is not quite right. To find the inverse of a function, we simply switch the x and y values. So to do this, I simply go 1, -2, 3, -1. Just switch their spots. So right now, fill in these last 2 spots and then graph the blue function. All right, I might need more time to graph. 2 more terms and graph. All right, I'm going to get 4, 1 and 5, 3. 1, -2 right here. 3, -1. 4, 1. 5, 3. And I connect the dots in that order. All right. Without looking at the table, is this blue line a function? Ignore the green one for right now. Is the blue one a function? This is a review from Monday. Graphically, by looking at this graph, can you tell me if it's a function?
Yes.
Yes, it is. So once again, if we ignore the green line, I do my vertical line test. I go across 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0. At no point does it hit 2 points that are blue. Good answer. That's a review from Monday. Now, these 2 are inverses. All right. What you're going to find about inverse functions is they end up reflecting each other. All right. Now, usually people expect reflections to happen flipping over the y-axis or flipping over the x-axis, but inverse functions flip over the line that comes through at a 45-degree angle through here. This imaginary line is the line y = x. Its y-intercept is at 0. Its slope is 1 over 1. So if I draw an imaginary line, y-intercept 0, up 1, right 1, up 1, right 1, up 1, right 1, I get a line that does this all the way through. And as you can see, it's a reflection of itself over that line. All right, I'm going to give you one to do right now from start to finish. I'm going to give you new data in green. I want you to graph that and the new blue one down here below. And where did I just put my problem? Sweet. Oh, come on. What the heck? There it is. All right. We're going to go -1, 0, 4, and 5. With -2, 3, 2, and 1. So graph both green and blue. The blue will be, remember, the flip of this one. Give you about 2 minutes to finish that. All right. So once again, all I have to do after I graph the green one is flip the values. I got -1, -2, left 1, down 2. It should be a little below it. 0, 3. 4, 2. Oh, I didn't go up high enough. Dang it. Dang it, I'm not good with numbers today. And 5, 1. So I have this funny looking creature here. All right. It's okay that it goes over the dotted line. They'll end up crisscrossing over that dotted line. If you do this right, we're going to go -2, -1, 3, 0, 2, 4, and 1, 5. -2, -1, 3, 0, 2, 4. Remember, I have to go in that order from left to right. I have to stay consistent. It's going to do that. And then at 5, at 1, 5 is right here. There we go. All right. As you can see, they stay reflecting over that line. These 2 points flip-flop, they flip-flop, and so on over that imaginary line if you do it right. Everybody good there? Any questions? All right. This gets you to the first page of your lesson packet. Like I said, 3 pages of the PDF. First one is this type of problem. The second is going to be more algebra-based. And then the third one is going to be a review of Monday and Tuesday. All right.
So was that one not a function?
That one was not. The green one was. The blue one was not. Great question. Everybody get that? The green one went like that. You could run the vertical line, but the blue one went back across. So right between 0 and 1, or between 1 and 2, it would not have been a function. Great catch. All right. Algebraically, f of x equals 3x minus 6. All right. We're going to graph again, but the bigger part of this is going to be the algebra piece. Okay. When we started doing function notation the other day, on Tuesday, we said f of x equals 3x minus 6 is a function. The same problem written as an equation is simply changing the f of x to a y. These two things mean the exact same thing. This is the function, this is the equation. They both graph a line in slope-intercept form, where our y-intercept is -6 and our slope is 3. All right? And remember that this does not mean f times x. It's just saying, hey, this is the function f. F is its name. We could have a function g, and g is its name. So right now, what I'd like you to do is graph this line in slope-intercept form. Once again, this is my y-intercept. We've done this numerous times. My slope is positive 3 over 1, so that means we're going to go right 1 and up 3. So graph that on your line if you haven't done so already. All right. So from here, I am going to start down 6. That -6 starts us down. 1, 2, 3, 4, 5, 6. Okay, from there, right 1 and up 3. Here, here, here. Pretty steep line coming through. Okay. I'm also going to put back in that imaginary line at a 45-degree angle that we had going last problem. Now, to find the inverse of something written in function notation, we're going to do something kind of similar. When we're done, our final answer is going to have f for function again, but it's going to have this little -1 with an exponent notation. This notation right here stands for inverse. So the inverse of the function we're looking for is going to be written. Our final answer is going to be down here. It's going to be something in slope, something in slope-intercept form. I'm going to teach you how to do that right now. The table was easy. All we had to do is switch the x and y values. All right. The function is similar in the fact that we're going to switch x and y, but then we have to get the y by itself again. So I'm going to change marker color from here to here. So now my inverse is going to start right now. I'm going to rewrite this equation, y equals 3x minus 6, but the x is going to come here, and it's going to be 3y minus 6. Everybody got that? All right. Now, What I need you to do now is solve for y. Get the y by itself. Use your algebra skills like you would before. What do I have to do to move the 6 over here? And then what do I do to move the 3 to that side? So go ahead and do that right now on your own. All right, so I'm looking for input here. Be ready to be called upon. All right. Cam, what do I need to do to move this -6 to the other side?
What are all the numbers? It's a little blurry on my screen. I don't have my glasses. Sorry.
Gotcha. So I got 3y minus 6. I want to move this -6 to the other side of the equation.
Distribute it.
We don't have to distribute it. I'll help you out here. We will add 6 to both sides. Opposite subtracting is adding. So I'll add 6 to both sides. And I'll get 3y equals x plus 6. If you're not seeing the far side of my screen, let me know. I can rotate the camera a little bit more.
Okay.
All right. Now, y is being multiplied by 3. Michael, what should we do to get rid of that 3?
Divide it.
Divide it, yep. So we'll divide everything by 3. All right. So on the right side, these 3's cancel, and y is by itself. And all I've done right now is I'm just moving the y to the left side so it looks like slope intercept. And I'm going to move this stuff. We'll go to the right side here. 6 divided by 3 is 2. Okay. Now, I like to have fractions here. What's the imaginary number that we don't see in front of this x right now?
1.
1. Yep. So we're going to have 1/3 x plus 2. So we have a new equation. It's y equals 1/3 x plus 2. And to get my final answer, I have 1/3 x plus 2. I just rewrite the same thing in function notation. So this is my answer. It's the same thing as the y equals. It's just written a different way. It's f -1 of x. Now I'd like you to graph that line if you haven't done so already. All right, so blue one here, I'm going to start up 2. Y-intercept up 2. Up 1, right 3, puts me at the same spot. Up 1, right 3. That's 6, 4. Down 1, left 3. We get this line here. All right. As you can see, they mirror each other over that dotted line. And if you look at them individually, just as the green line by itself and just the blue line, they will both pass that vertical line test. So I look at just the blue, it's only hitting one spot. And the green, even though it's steeper, it's only hitting one spot as well. All right, last problem of the day. This next one's got a fraction in it, so it's a little bit more difficult. So I'm going to work the way through this problem with you. All right, here's the function. It is f of x equals negative 2/3 x. I'm going to use green, dang it. Plus 4. So right now, graph that function. And this fraction is going to cause us a little bit of headache, but I'll work through that with you in this example. All right, as I graph this, we're going to start this time up 4. Okay, I'm going to go negative 2/3 slope is down and right. So we're going to go down 2, right 3. Down 2, right 3 puts us right here. And I'm going to get a green line that does this. All right. I'm going to rewrite this equation with a y. Y equals negative 2/3 x plus 4. That's the exact same function. And now I'm going to switch marker color, and I'm going to go to my blue marker. I'm going to switch these. I'm going to go x equals negative 2/3 x plus 4. That starts the inverse process. All right. First step is pretty simple, pretty basics. What do we do to get rid of a plus 4?
Subtract -4.
Yep. Yep, we'll subtract 4 from both sides. I will get x minus 4. And I have negative 2/3 x. Now here's the little bit that's a little bit tricky. I have a fraction here. So I'm going to do this in 2 steps. There's a way to do it in 1, but it can be a little more confusing. So I'm going to just do it in 2 steps. I'm going to get rid of, we have our function being divided by 3. Okay. How do we get rid of dividing by 3?
You multiply.
We'll multiply. When I do that on the right side, they'll cancel. When I do it on the left side, I got to put this in parentheses and multiply it by both terms. So I'll end up getting 3x minus 12 equals negative 2x. And then it turns into something we're familiar with. This x is being multiplied. This is not subtracting 2. It's being multiplied by a negative 2. And just like when we multiplied everything by 3, we are now going to divide everything by negative 2. Oh, this is oh, idiot. These are y's over here, guys. I'm so sorry. Okay, I get y equals, they canceled there. A negative 12 divided by a negative 2 is a positive 6. And now a negative by a positive is a negative 3/2. We just moved the negative from the bottom to the top. I'm going to wait a second here and make sure everyone gets caught up. All right. Everybody understand how we got this negative 3/2 here? Once again, if I have a positive over a negative, it's the same thing as a negative over a positive. We always move the negative to the top. That way we know we always go right. Any questions before we finish up the lesson on this equation? We're going to start up 6. Positive 6 is up here. All right. We are going to go down 3, right 2. Down 3, right 2. Right about here. Down 3, right 2. Puts us here. Do it one more time. All right. As you can see, they're both functions again. They meet over that line, reflecting, and it's done. Do not jump off the medium. I'm going to take attendance here in a second. Anybody have any questions before we end the lesson itself? All right. I'm going to stop the recording.